All right, good afternoon and happy Monday. Taking a lunch break to do a little leak coding here. Let me share my screen. All right, here we go. Okay, so I'll plan on doing leak code contest 327. So I did the bi-weekly contest. I got 3 out of 4. So I'm totally stoked to try this one out. Let's see what happens. Here we go. Time to shine. Open these guys up. There we go. Okay, so count the positives and the negatives and return the maximum. Counter for x and a if x is less than, what about 0? 0 is neither. Okay. I guess let's do this positive and negative. Negative plus equals 1 if 0 is, if x exceeds 0, then positive. Turn max of negative and positive. All right, it's accepted. Nothing too fancy. That was accepted at about 1 minute 12 seconds. 1 minute 12 seconds for AC. Nothing too fancy. It's always fun to start these out on a positive note. Nothing too challenging here. A few solutions. All right, let's do this. Go in. JavaScript. Python 3. Rust. C++. Okay. So I'm wondering if we can shorten this up a little bit. It seems pretty concise. Nothing fancy at all, really. We can filter the array twice too. So this is procedural approach, right? Procedural. We can also do functional, right? So functional would be filtering it and such. Return the maximum of the length of the positives and the length of the negatives, right? So x for x in a if x is less than 0, x for x in a if x exceeds 0. Three, 3, and 4 looks good. Yeah, nothing too fancy. Yeah, this is kind of nice just to keep it a little bit shorter. And let's get rid of that guy. Just have a true one-liner. So negatives and the positives, the cardinality of each, and take the maximum. Okay. Yeah, nothing too fancy. Okay. Let's do this. JavaScript next. How about? All right. Maximum of a.filter. X is less than 0. Negatives. A.filter x where x exceeds 0. Take the cardinality of each and return the maximum. There we go. Looks good. Wham, bam. Okay, Rust. I don't think I can change this to a one-liner. explicitly, but I can just return a dot clone into, or actually I can just iterate through. I don't need to iterate. Right, okay. A dot iter dot filter borrow x. The object in the location of x is less than 0 dot collect into a vector of integers. Just to shorten it up a little bit. Collect. Yeah, I think we do want into iter. Let's just do that. Into iter, collect them to a vector of integers, length, maximum of this guy, and that guy, right? The negatives and the positives is max. Okay, let's see what happens. Whoa, borrowing it. Okay. Okay. Whoa. Especially 32 find the U size. Move. Doesn't implement the copy trait. Oh, okay. I wonder if that'll work. I don't think so. Can we just iterate through the same thing twice? And borrow it? Yeah, maybe. Yeah, those are references. Let's just do this. I think that works, right? You see move, a clone copy. Consider borrowing, okay. Looks good. Not the most efficient, but it's short and concise, whatever. Yeah, this one I think we do want to do iteratively, right? Or do that or partition it. We just copy if. Oh, let's just do this. X is less than 0, increment negative. It's fine. Okay, in Kotlin, I just do this functionally. Maximum of these two choices. A dot filter is less than 0. Filter. It is greater than 0. Looks good. Alrighty, easy steezy. And the maximum. Ignoring zeros, right? Read the problem statement, I guess, right? Sound good? Return the maximum cardinality of the negative and positive partitions of the input array A. No. Oops. What did I do? Copy and paste this. Not the C++. Yeah, that's good. Okay. Yeah, nothing too fancy. Okay, we have 1 hour, 18 minutes remaining in the contest. 1 hour, 18 minutes. Here we go. Maximize our score. We want a priority queue, I suppose, right? Game plan is priority queue. Does that work? Right, heapify this thing. Just take the biggest. Heapify the queue. Actually, hold on. We need to just do this. Heapify negative x for x in A. By default, it's a min heap. Best is the maximum we can take. Take equals heap use this, and then we'll heapify our queue. Okay, heap pop the queue is what we'll take. Negative, two negatives make a positive, right? Mass once equals take queue. Now heap push onto the queue. Take floored by 3. Let's put it here. How about negative take best to the end. Okay, let's see what happens. Take 50 and 17. 50 and 17. Looks good. Yay. Okay, 1 hour 18 to 1 hour 15. 1 hour, oops, 15 minutes. So that's pretty cool. That took about 3 minutes. Yep. 3 minutes for a game plan plus implementation in Python 3, which is AC. Yay. That's pretty cool. Okay, nothing too fancy. Just a priority queue, a max heap. Okie dokie. A few solutions. Use a max heap to greedily consume the top. Okay. Values of the input array. All right, let's do this. Kotlin, JavaScript. I use my own gist for that one. Python 3, C++. Okay. Boom. Okay, that looks good. Okay. Look at the constructor priority queue. Forget exactly how this thing's set up. Let's do the constructor. Less is default. Where's the constructor? I want to look at the constructor, right? This is a constructor, okay. Input comparison. Container. Input iterator. Huh. I wonder if that works in Q. Container. What is container though? Yeah, whatever. Let's just do this. Q. That's not right. Maybe it is right. The default then. Is it a max heap by default? 50 and 16. Should be 17. Take 2 by 3. What's the ceiling? Oh, that's surprising. The ceiling. How is it? Ceiling must round up. Interesting. Hmm. Ceiling. Hmm. Okay, yeah, C++ is a max heap by default, whereas Python 3 is a min heap by default. I wonder if I can initialize this thing. Let me try right quick. Oh, it does work. Okay. That's a little bit better. The documentation sucked. Okay. Anyhow, that's good. Okay. Let's do this in JavaScript, and I'll pull my gist from my min heap. Just go to heap. This guy is what I want. Okay, there's my heap. Oops. Ready. Let Q. Stick this guy here. Heap push X onto the Q. Okay. Oops. Okay. There's our best. Heap hop from the Q onto a max Q. Hop from the Q. Heap push Q at ceiling of take divided by 3.0. Okay, that's good. That's cool. Okay, Kotlin. I didn't think it like that. Priority queue. Mutable collection. Does that work? Nest. Looks like it compiled okay. Okay, yeah, that's cool. So var take goes q.pull. Yes. Oops. Take and then q.add at.ceiling of take divided by 3.0. Yeah. Oh, that's all right. If it's a minimum or maximum, what the heck? Natural ordering. Okay, must be I'm in heap then. I just do the negative check. Floor of a negative value is the ceiling of the positive. It's good. Looks good. Okay, that's cool. Nothing too fancy. And then we have 1 hour, 1 minute left. And we are on Q3. All right, 1 hour, 1 minute. Okay, word one, word two. Exactly one move. Three distinct characters. Suppose we can use integer to represent 0 through 25 inclusive for the ASCII ordinal values of A through Z correspondingly. This is distinct characters, so it's two sets. They need to be completely disjoint sets, like completely disjoint, or off by one. Okay, so the game plan is to return true if and only if S and T are disparate, non-intersecting sets, right? Then you can swap any arbitrary values and it doesn't matter, they don't overlap. Case 2, S and T differ by exactly one character, right? One character, and we can move one instance of that character from S to T, or vice versa. Okay, that seems like a good game plan. All right, so scene A will be set with a list of characters, set to the list of characters of T. If not A and B, return true. Right, they're completely disparate. The other case is they're off by one. Set difference. Let's see, I'm just gonna print this out and see what happens here. I think that seems to work. Just return false down here. Okay, actually A, C, and B are completely distinct. Oh, so this is a different, completely distinct. And they have to be the same size. They are off by one, but there's not one extra one to borrow. P minus A equals 1. A minus B. Let's just do this, print. A minus B is 2. All this without that. All this without that. How do I want to do this? There's something here that's not there. All right, all of them should be the same. Actually, shouldn't. One should be completely encapsulated in the other. A and B is equal to A. If A and B is equal to B, this should be this example. A and B is equal to B 2. Good. Come on. 2. Okay, good. A and B is equal to B. So this means B has something extra. There's 2 or more. A has something extra. A is the character. I don't know if that works or not, but let's try this. Go to A. Set hashable type set. Invalid syntax. All right, debug this. Let's see. Characters A. What? She's my character is all 3. Oh wait, no, it is C. Okay, C. A, B, C, which is B minus A. Okay, B minus A. Counter S sub C. Oh, should be T. Oh, okay, that works then. Okay, I can make this a little more succinct, I think, too. Okay, let's see. over C and A minus B. Counter S of C. Okay, something like that. False, true, true, false, true, true. Let's see what happens. Uh-oh. It's true, but I expect oh. Oh, we have to swap it with something else. Okay, so it needs any other character to swap it with. Okay, any other character. Then I'll swap it with some other character. Right. So we need an alternative character to swap it with. So it needs an extra any other character. Hmm. Let's see, this is only a 4, so maybe I'm making this way harder than it needs to be. All right, what if we just back up and take a break here? Remember, ASS, it's super simple. Be right back. So originally I was thinking maybe a bitwise implementation, right? A bitwise representation. So this set, this might not be as simple. It's just a bits of a 32-bit integer. All right, so question, what if we go back and consider, right, reconsider how we are tracking each set of characters. Above, I was using Python 3 sets. What if we use an integer instead, right? It's 0-25, which should represent A through Z inclusive, right? Ordinal values. A to B is 0 and 0, or C and S. A or equals 1 bit shifted by the ordinal value of that character offset by ordinal value 1 of A. Let's do this. T, call this guy B. Oh, excuse me, bless me. T, it's encoded as a, oops, B. Off by 1 bit. It's off by 2 bits. 3 bits, right? Off by 3 bits. I think this seems promising, right? So 5 is this guy. 2 is that guy. So that's no good. It's off by 3. Oh, wait, hold on. We need to know how many of each as well. Yeah. I need to consider the count. Now 7 is 0, 1. 3 is 0, 0, 1. This is okay if we have 2 or more of the extra, which we can swap with any other 2 or more. Two or more. It should be any. So yeah, whatever. That's pretty close, I think. If we consider any other 2 or more, return true if and any counter s dot values is 2 or more, right? I think that works. Something like that. Let's see. Grab this guy, stick it here. This should be no, this should be false, right? Oh, int and dict values. What? Sure. Does that work? I don't know. Switch to false. Okay, that looks good. Oof. It's true, but it's supposed to be false. Really? It's true, but it's supposed to be false. What's true, but it's supposed to be false? How is this true? The hell? It's not here, is it? Here's 0. Oh, crap. Okay, so that is false. Okay. Here, let's make sure we don't have any regressions. Oops. True, false, true, true. False, false. False is correct. Okay. These debug prints, see what happens. Oh, alpha's false, but we expect true. Oh man. Here, I think I get it now. Just brute force. Try them all. I wonder. Try to replace him with every other one. We have 26 to choose from. And we have 25 to choose from for the other. Hmm. There's got to be an easier way to do this than what I'm doing it, right? I mean, come on. Just like piecemeal fashion. Oh, I forgot that case. Oh, forgot this case. Right, for each of the 26 characters, consider swapping it with all the other 26 characters. Right? It's 26 times 26 is tiny, isn't it? You swap X with Y. Otherwise return false. Oops. Come on. Okay. That does not look right. Oh, oops, this is a set. I don't know. Oh no. The characters. False, true, true, true. So this one should be false. This one is also answer. This should be false. This is true. How is this possible? So, okay, A and B. B goes there. Mm. I only swapped one of them though. I only swapped one of them, not all of them. Continue through the same character, right? Okay, so that was good. This should be false. This one should be true. And that looks right, but I don't know if it'll TLE or not. It might TLE. Let's see. False, true, true. False, true, true. This should be. Yeah, that one's false. False. True. Okay. I mean, it's okay. My TLE. Yep. TLE'd. Okay, these things are massive. Okie dokie, so that doesn't work. For each character in this guy, for each character in that guy, try swapping them. An instance of them. Yeah, I got 27 minutes left, so let's move on. 10 across the bridge. Just perform the simulation, it seems, and then have a priority queue on each side. This is like a lot of work. I perform the simulation. Simulation. Yeah, part of me thinks, yeah, I might as well stick with Q3. Start not him on the. So okay, you got 24 minutes. 24 minutes remaining. I just need to make this more efficient. It doesn't matter which instance of each, though, right? So continue, otherwise it's I seen as and okay. Seen T to N, T sub J. That'd make it more efficient. Okay, maybe that's good enough. Oof, wrong answer. Hope it's false, but expect it to be true. One of those C's from here to there. What? Right. S. And B as we try them out. S sub 0 is A. T sub 0 is A. So the A and the A don't really do anything. S sub 0 is A. Which we continue, right? Wait, no, don't continue. What is going on? What the heck? What? How is this possible? How's C already seen? What the heck? S sub 0 is A, T sub 0 is A. Fine. Skip the second T. A and B. B up there. It's not the same. It's fine. We can skip the A within T. Or in B and B. I think that there'd be. What the heck? All right, I'm not totally worn out. Not seeing some basic stuff now. Yeah, this is one of those things I can come back to and come up with a better solution. Right, this just like spinning my wheels on something fairly basic, right? With a lot of corner cases though. This is weird. What the heck? A is supposed to skipping the TA, okay. Adding B, scene for T. Okay, so we do want it to be a set in there then. I see. Okay, I was skipping past them all because that, okay, that makes sense then. Okay, all right, fine. It saves me a little bit of time, but it's questionable how much. Let TLE, I don't know. See what happens. TLEs, okay. Yeah, this input's just massive. Okay. All right. Let's take a break. So okay, so I'm sure I can do this with a bunch of if cases, and I can consider every single edge case. And maybe that's the path of least resistance, but it just seems so verbose and ugly. Maybe just, I don't know. Yeah, it seems like I am pre-optimizing, so I'm skipping some steps of actually having a solution that, well, I mean, I guess optimize it, conciseness, right? Basically, that's what I'm aiming for is code conciseness. I don't want to make it terribly too verbose and ugly, but that might be the path of least resistance. Okay, get y'all next time.